Hi, boys and girls. In this video, we are going to recap the topic lenses and optical instrument in Form 4, Chapter 6. As you know, there are two types of lenses we have learned. First, convex lens. Second, concave lens. In the formation of image by the lenses, we have to follow the three rules. Let's start with the convex lens first. As you can see from the animation, light rays will bend after enter the lens due to the phenomenon of refraction. There are three rays used in the construction of a ray diagram. First ray, which is parallel to the principal axis, will bend to focal point at another side. Second ray, which passes through the focal point, then will bend parallel to the principal axis. Third ray, which passes through the optical center, travels in a straight line without refraction. The following animation will show you how is the formation of image. Please watch properly. What is the changes of the image when the object is moving closer to the lens? Yes, the image is become bigger and it is changing from inverted to upright. Most of the situation, two rays are enough to get the intersection and the image. And at the right side here is the animation about the formation of image by the concave lens. What can you say about the image characteristics? For the concave lens, the image is always smaller and upright. We will study more about the characteristics of image in the following slides. This time we use a real person as the object. Case 1. When the object is beyond 2f, the first ray will bend to the focal point, and the second ray pass straight the optical center. The image form is real because it is at another side of the lens, and it is upside down, or we call it as inverted and diminished. We can remember the characteristics by the word of RID, read. Case 2. The object is at 2f. What is the image characteristics you can see? Yes, it is real, inverted, and same size, or we can call it as reads. Case 3. The object is between f and 2f. What is the image characteristics you can say? Yes, the image characteristics is real, inverted, and magnified, or we can call it as rim. Case 4. The object is at f1. Where is the image? The image is formed at infinity, and it is most probably at the same side with the object. So we can say the image is virtual, upright, and magnified. or we can say boom. Case 5. The object is in between F and optical center of the lens. What is the image characteristics? Yes, very obviously we can see. The image characteristics is virtual, upright, and magnify. Or we can say it as zoom. Now, let us study the rules of image formation by a concave lens. Rule 1. The ray which is parallel to the principal axis will refracted and appears to come from the focal point at the left side. Rule number 2. The ray passes straight through the optical center without bending. Rule 3. The ray which travels towards the focal point F will bend parallel to the principal axis. So now we look at the case 1 for concave lens. The object is beyond 2F. The image characteristics we can see is virtual, upright, and diminish. Or we can say it as wood, V-U-D. Case 2. When the object is between F and 2F, the image still formed between object and lens, and same characteristics as case 1 just now, which is wood, V-U-D, virtual, upright, and alright. Now, this slide shows another case for convex lens where the object at infinity. The image is real inverted diminish. And second case you have learned just now, the image characteristics is also real. And third case just now you also learned, the image characteristics is RIS. Following cases RIM, R-I-M, and VUM, and last one VUM, VUM. So we can easily to remember all the 6 cases by just remember the 6 short words. We can start with read, ris, rim, vum, vum. Okay, so now here is the formation image by concave lens. So as you can see, the image characteristics is VUD, wood. And the second cases also same, VUD, wood. Which means any position of object for this concave lens will always produce the image which is wood. Now we are going to study the uses of lenses in optical instrument. First optical instrument is telescope. Telescope is made up by 2 convex lenses. The lens that close to our eyes is named as eyepiece lens, and the lens which is larger and further from us is objective lens. As you can see, there are 2 different thickness lens is used in telescope. First lens at the left side is thinner. This is objective lens. It has long focal length, FO. Meanwhile, eyepiece lens is always thicker. It has short focal length, FE. We assume that the object is come from very far. So, two rays are coming from distant object, from very far object. After enter the objective lens, they will focus at the focal plane to form the first image. This image has the characteristics of real, inverted, and diminished. The first image formed will become the object for the second lens or eyepiece lens. The eyepiece lens will form the final image, which is virtual, inverted, and magnified, or we say WIM. Telescope is always adjusted so that the final image is at infinity, and then the eyes is completely relaxing when viewing it. So, this adjustment is known as normal adjustment. When the L is equal to the FO plus FE, the length will be equal to the focal length FO plus the focal length eyepiece. Telescope modification. This slide is very important because you can use the information on the table to answer the question asked in section B or section C, paper 2. This is a 10 marks question. So now we look at the information in the table. First, we use convex lens for both lenses in telescope so that all the light rays will be focused or converged. Second, we select the focal length of the objective lens all the time larger than the focal length of the eyepiece lens. This is to produce higher magnification because the formula of magnification is M equal to FO divided by FE. Number 3. U at infinity means the object is very far, so that you will get the image which is a RID. The first image, real, inverted, and diminished. Next, second object at the FE. The purpose is to make sure it can produce the final image which is VIM, VIM, virtual, inverted, and magnified. And last, the normal adjustment for telescope is always L equal to FO plus FE. Okay, so the explanation is to produce sharp and bright image. Microscope. As you can see, eyepiece lens is on the top of the microscope, and objective lens this time is at the bottom. Microscope ray diagram. We have two lenses. Objective lens is thicker, so it has a shorter focal length, FO. Meanwhile, eyepiece lens is thinner, so it has a longer focal length, FE. Now, look at the bacteria. It is located in between FO and 2FO. So this is the position of the bacteria. So we can start with the ray diagram. First ray moving parallel, and then it will bounce to the FO. Second ray moving past through the optical center and without bending. So you will get the image which form in this area. What can you say about the characteristics for the image? Yes, it is real, inverted, and magnified. Rim. Then look at this first image. It will become the object for the second lens. And this bacteria is located in between the Fe and optical center for eyepiece lens. So it will has a magnifying effect later on. We continue to draw the ray diagram. When the ray is moving parallel to the optical axis, it will bend to the Fe point, and second ray, when the ray is moving pass through the optical center, it will go straight without bending. So at the end, you will produce a final image at this side. So what is the characteristics? It is virtual, inverted, and magnified. So the normal adjustment for this one is always L larger than FO plus FE. Microscope modification. We use convex lens as the lens to build out the microscope, so that all the light rays will be focused or converged. Second, we select the focal length of the eyepiece lens, which is longer than the focal length of the objective lens, so that you will have the low power of the lens. From the formula, P equal to 1 over F. F, you have to change the unit to the meter. But the relationship is when you have a higher value of F, you will get the low value of power. So, for the focal length of objective lens, when the lens is shorter, it has a higher power. Next, for the object distance U, it should be located at FO and 2FO, so that the first image will be RIM, real, inverted, and magnified. And then last, the normal adjustment must be all the time larger than the FO plus FE, so that it will produce bigger image from the eyepiece. Magnifying glass modification. As you can see, there are also a table you need to remember and how to answer this in the section B or section C in paper 2. First, we need to use convex lens. Why? So that all the light rays will be focused. Second, we need to select bigger diameter of lens to make the magnifying glass. Why? So that more light can pass through the magnifying glass and can produce brighter image. Number 3, low density of magnifying glass. Why? So that the weight is lighter and it is easy to handle and portable. Number 4, U must be smaller than F, so that it will get the final image, which is virtual, upright, and magnified. Last one, the refractive index of lens must be higher, so that it can produce bigger and sharp image. Or you can say more light can be focused. Okay, after you have learned the theory, now we have a few questions we are going to discuss together and try out together. Question 1. The diagram shows the design of a simple astronomical telescope. the focal length of the length P is FP. Okay, so you have to determine length P and length Q, which is objective. Okay, as you know, the length that's near to our eyes will be eyepiece. Okay, this is eyepiece length. Then this is objective length. Next, FP. Since FP is objective focal length of objective length, so it should be longer. It should be longer. Okay, we change this one to FP. And then FE, eyepiece usually is nearer to our eyes, is shorter focal length. Okay, so here we follow the FQ, eyepiece is FQ, focal length will be FQ. Okay, at the same time you have FQ here. Okay, FP and FQ. Now look at the statement. FP shorter than FQ. Okay, not correct, right? This one should be longer. Okay, from the optical center of length P to the focal point, as you can see, it should be longer, not shorter. So this is not our answer. Second, the power of length P is higher than length Q. Okay, how to determine the power? Okay, you have the formula P equal to 1 over F. Okay, 1 over F, and the value of F must change to meter. Then as you can see now, okay, this is changed the unit to meter. But since the F focal length is longer, okay, is longer for length P, so it should has a smaller or shorter power. Okay, so this is not the answer. It should be shorter power or lower power. Okay, so B out. C, the image of length P is real, whereas the image of length Q is virtual. Okay, so length P is real, the image, whereas the image of Q is virtual. Actually, yeah, you understand that the object is from very far away from here. After enter the first length P, it will produce an image somewhere here, right? Somewhere here. So it should be RID. That is the first image characteristics read. So read here, yeah, you have real. Okay, and then the virtual image for length Q. Because final image, okay, second image will be VIM. Remember that? Ring. WIM will be the final image characteristics WIM. So it is virtual, upright, and virtual, inverted, and magnified. So seems it's okay. So the answer should be C, right? Then we look at the image magnification for ratio is FQ to FP. Okay. In fact, magnification it should be FO or objective divided by eyepiece. Okay, or it should be FP in this case divided by FQ, which means this ratio is also wrong. So the correct answer is C. Question 2. Magnifying glass. Ray diagram, as you have seen before, our eyes is at the right side here. So this is magnifying glass. You're holding the magnifying glass, and the object should be very close. Yeah, should be very close to the lens, and we want the image magnified. Okay, so this is a use convex lens. So this is the lens that we want. This one also However, when our eyes is somewhere here, okay, you cannot get the image. If you should get the image is somewhere here. Yeah, your image will be here. So this is not the answer. And question C, answer C and answer D is also not our answer because they are using the concave lens. Right, so the correct answer, A. Question 3. Again, this is a question asking what are the required conditions for the lens to be used as magnifying glass. Okay, so you have studied just now. The only lens we can use to make magnifying glass is convex lens. So the answer C, concave, D, concave, out. Then object distance must be very near to the length. So it can less than f focal length. So it's not suitable to have f and 2f. So the answer is A. Question 4. An object is placed at different object distance U in front of a convex lens K. So you have many characteristics to remember. But if you follow the way I taught you just now, how do we remember the characteristics for convex lens? Especially the first case when the object distance is at infinity. Okay, we start from the bottom. So the clue given here Ri and some missing. One characteristic is missing. So RID will be the characteristics for this answer. Next, going up, here we have RIX here, and formed at infinity, virtual upright larger. So this is a VUM. Okay, VUM. Remember just now we have learned how to read all the 6 cases in convex lens. There will be RID, read, RIS, ring, voom, voom. Okay, so you just fill out the information, fill in the information. Okay, fill in information. That will be the answer for this table. Let's check. Okay, so as you can see, RID, the answer will be real, inverted, and diminished. And when the object distance U is 15 centimeter, okay, you will get the real, inverted, and magnified. So you can get it very simple by just remember the 6 words: read, ring, boom, boom. Look at the question A1. Based on the information given in the table, you have to state the focal length of length K. So from the table, which means you have to refer to the table. Okay, if you are able to recall back your memory, when the object is at the position 10 centimeter, the image form, okay, the object distance is equal to 10 centimeter, the image will form at infinity. Okay, image form at infinity, which means this time, okay, you can understand that U will be equal to F. Okay, U equal to F. So F will be equal to 10 centimeter. So the answer will be 10 centimeter for A1. You need to write down your reason in the A2. Yeah, this should be A2. Yeah, this one also A2. Okay, so the reason is when the U equal to focal length, so focal length now is 10 centimeter because the image formed at infinity. Second reason also you can use is when you can see the characteristics of the image is same side with the object. At that moment, the U object distance is equal to 20 centimeter. So we understand that time U should be 2F. So 2F equal to 20 centimeter. 1F, of course, divide 20 by 2, you get the answer 10 centimeter also. So you can have two ways to find out the focal length of a lens. Next question, complete the information. This one we have done just now. Okay, we have done in previous slide. Look at the question C now. An image is formed on the screen when an object is placed 20 centimeter from length K. 20 centimeter, which means it's from at the position 2F. Okay, because length K has a 10 centimeter. Yeah, length K has 10 centimeter. So 2F will be 20 centimeter. So this time you have a cardboard is placed in front of length K. So I just draw the situation like this. So you have using a black cardboard to cover and to cover partially of the length K. This is length K. So the object is placed. Maybe this is F point. Maybe this is 2F point. Yeah, 2F point, 20 centimeter. So this is your object, for example. Okay, so what can you expect? Any changes to the image form? Yes, it has changes on the image. The changes of image is the image will become blur. Why? Because partially of the lens is covered, which means you have only allowed partially light enter. You only allow certain amounts of light enter the lens. So confirm you will get the image blur. Question D. To build a telescope. So the student use length K. Again, we understand F is 10 centimeter as eyepiece length. And another length, convex length will be objective length. So can we select objective length which has smaller focal length than 10 centimeter? The answer is no, because remember, we want the magnification always larger, which means FO, focal length of objective length, should be all the time larger than focal length of eyepiece length. Okay, for example, we select 20 centimeter as the focal length for this time. So we can see the magnification, the ratio, how much? 20 divided by 10, you have two times larger. So let's say we have 20 centimeter is suitable for the length. Then we continue to second part. If the student wishes to build the telescope in normal adjustment. Normal adjustment, what is the meaning of normal adjustment? Okay, so recall back. During the normal adjustment, okay, L will be equal to FO plus FE. Right? The length, the distance between the two lenses, between the two lenses will be L, capital L, normal adjustment, or it will be equal to focal length of eyepiece plus focal length of objective length. So the answer will be 20 centimeter is objective length, focal length of objective length 20, and FE eyepiece 10. At the end you get 30, 30 centimeter. So 20 plus 10 centimeter, you get the answer. The normal adjustment will become 30. So let's check the answer. Or if you use 40 centimeter here, for example, you select 40 centimeter, you don't want to use 20 also can, as long as you select larger value of the FE. Then let's say you select 30 30. Then 30. Later on the formula you apply, you substitute 30 into the formula, you will get 30 plus 10 will become 40 centimeters. So the normal adjustment will change to a new value. Depends on what is the focal length that you are selected in part 1. Question D. You are given an eyepiece with a focal length 5 centimeter. So you need to calculate. You need to calculate the magnification. Okay, you have the formula m equal to mo over fe. Okay, so this should be fe. Not like this. It should be fe. Like this. So you have 5 centimeter. So we become 10 divided by 5 equal to 2. This one also 2. This one focal length of length FO, objective length 40. 40 divided by 5, you get 8. Okay, you get 8. Get 8. This one also you get 8. Simple, right? Okay, part 2. Choose two lenses that produce the largest image. From the table just now, okay, try to select the two has the highest magnification, which is 40. The magnification value is 40. So R and X is the answer. Next, give a reason. Of course, largest magnification. And we continue. Choose the two lenses that produce the brightest image. So brightest, it should be Q and X. Why? Both lenses have largest diameter. So based on the answer in HD number 2 and HD number 4, select the most suitable length as the objective length. Right? So it will be X. Here appear one time, then here appear a second time. So X will be the best choice. Question 6. This is exactly question come out in SPM 2014. Look at the A. Name the type of lens. Very simple and straightforward. Convex lens. Then you need to draw the ray diagram. Of course, follow the 3 rules. Parallel and goes to the F. Then pass straight through the optical center. And you might need to extend the line behind or at the left side here. Extend. Then you will get the image. Because this is the magnifying. So magnifying, remember, object distance must be in between optical center and the focal length. Then your eyes must be at the left side. Your eyes should be at the left side. That's why you can see the image is larger. So the two characteristics, which is a vertical and upright or magnify. Question C. This is the question about a compound microscope. So you have given 3 different distance of object and different distance between the 2 lenses. So they are arrangement J, K, L. Based on the table given, you need to select which arrangement is suitable to build a simple compound microscope. Look at the part 1. You need to select which object distance is suitable. As we can see from here, we have to select this one. The object distance must be in between f and 2f. What is the reason? So that the image form is real, inverted, and magnified. Rim. So that the first image is rim. Then look at the second part, distance d. Distance d is the distance between objective length and eyepiece length. So we have to select larger. D larger than FO plus FE because this is normal adjustment. Part 3. Select the object distance UI. The object distance for eyepiece length should be smaller than FE so that you will get the magnifying effect as the magnifying glass. Remember just now, it should be in between F and O, optical center. So we select UI smaller than FE. Reason, the final image will be richer, magnified. Based on the combination, we select L is the best choice of arrangement. Question 7 is the last question about a telescope. Based on the information in table 9.1, you need to help Azri to choose the suitable telescope. We have to choose the suitable telescope based on the following aspect that's given. First, thickness of objective length. Second, distance between objective length and eyepiece length, D. Number 3, distance between the image formed by the objective length and the eyepiece length. And last one, type of objective length. First aspect, we select thin thickness for objective length so that it will have the longest focal length. We write a tick on the table. Second aspect, the distance between objective length and eyepiece length, D, must be equal to FO plus FE, so that it will form image at infinity. Aspect number 3, we select the focal length of eyepiece length must be smaller than focal length of objective length. The reason is it will produce a richer inverted image. So we write the tick also on the table. Last aspect is we have to select the types of objective length. The suitable length is convex length because this type of length can produce many images at any distant object. So from the table, which telescope is the most suitable? Yes, you can see the most suitable is telescope Y because telescope Y has thin thickness of length and it has FO plus FE adjustment and the focal length of eyepiece is less than the focal length of objective length and it is convex length. That's all for my video. All the best. May God bless you.